this is TIPERSD number 14 from the circuits chapter. And it's asking us to rank the voltage or the potential difference between these 2 points across a light bulb. And notice that this light bulb is getting all the current coming from the battery in each of these cases. After that, it splits. In cases B and C, then we have this branching here. So we've got in B and C a case of combination series and parallel circuits, and in A it's just a simple series circuit. So when we look at comparing these, for A, if we have an increase of voltage across the battery starting from the negative side going to the positive side, it's pretty simple to compare, these 2 identical light bulbs to each other. We'd have a voltage drop of IR across the first bulb and then same voltage drop across the second bulb. So, and because these all must sum to 0, then each bulb in case A would get half the voltage of the battery. Okay. But looking at case B, it's a little more complicated. We know that the loop rule still holds true, that each loop must sum to 0. But the current is not the same everywhere. And in fact, the total current going through that first bulb that we care about is not the same in B as it is in A. And the reason that is adding this extra branch here now is reducing the total resistance of the circuit as a whole. So having this extra bulb in here in parallel actually is going to increase the total current going through the battery and coming out of the battery. And so we could argue now that having that additional bulb in there reduces the equivalent resistance of the whole circuit, which means that the total current coming out of the battery here is going to increase. And so then we can argue that the voltage drop from M to N is going to be larger in case B, because now I've got, the R hasn't changed, but I've now got a larger total current that I'm multiplying by that resistance. And C, again, will be larger because I'm again reducing the equivalent resistance and increasing total current and therefore increasing the voltage drop across that bulb. So that alone can help us explain why the ordering is greatest voltage drop across this light bulb in C, then B, then A. Okay, I sometimes like to plug in numbers to check that. So you could stop there and make this argument and explain your reasoning like that. I am going to just do the math for the first 2 cases and give some numbers to these variables, but you wouldn't have to. Okay, so let's if you want to keep watching here, let's say that the voltage across the battery is 12 volts, and let's pretend that all the bulbs have a resistance of 2 ohms. Okay, and let's tackle case A. Then we would like to know the voltage drop across MN. We need to know the current. So let's find that first. We know that the equivalent resistance for a series circuit is just the 2 resistors added. Okay, that means total current will be 12 over 4, which is 3 amps. So then the voltage drop for MN, okay, is going to be negative IR, so that's going to be negative 3 amps times 2 ohms. So it'll be a drop of 6 volts, which is what we expected. It's half the voltage of the battery. But then for B, well, we kind of would like to reduce this parallel part. Okay, so I'm going to take this parallel part and get its equivalent resistance. Some people would do that in their head. They'd say, well, if I have 2 pathways for current to follow and they're each the same resistance, then I'm going to cut the resistance in half. But let's do the math here. So basically, let's first find the parallel part. Reciprocal. Here's the formula. Just the parallel part now. 1 over 2 plus 1 over 2 is 2 over 2. Take the reciprocal, okay, but that's just still 2 over 2. So just the parallel part is 1 ohm. Okay, so I get double the pathways, half the resistance. But then the overall equivalent resistance, taking the whole circuit, is that first bulb plus the parallel portion. Okay, and then find the current. So voltage over resistance gives me 12 over 3. So now I'm getting 4 amps worth of current, which then when I calculate the voltage drop from M to N, I can see that I'm going to get a bigger one. So I'm doing negative times 4 amps, 2 ohms, and I'm getting negative 8 volts. So the magnitude is a bigger drop, 8 volts versus 6, and then C would go up again. So that's just some math to help me back up my answer in case I wasn't feeling secure about my ranking here. Okay.